Hello everyone. So today we're going to go over section 0.7, Trigonometry Part 2. So we'll begin by proving some trigonometric identities. So here on the left hand side we have sine x over 1 minus cosine x. And what we're going to do is multiply by the conjugate, 1 plus cosine x, in both the numerator and denominator. Okay, so once that's done, on the left-hand side, we have sine x plus sine x cosine x in the numerator. And of course, since we multiplied by the conjugate, the denominator will now simply be 1 minus cosine square x. Now, using the Pythagorean identity, we know that 1 minus cosine square x is the same as sine square x. So if we were to use that, then the left-hand side becomes sine x over sine square x plus sine x cosine x over sine square x. Now, of course, the first term is simply going to become 1 over sine square x as we eliminate one factor of sine x. And the right-hand side, very similarly, we just have cosine x over sine x. So something like this. Let's go ahead and rewrite the 1. So from there, oh, sorry about that. That is not squared. That is actually just sine x. So from there, we know that the 1 over sine x is, of course, cosecant x. And cosine x over sine x is cotangent x. And now we have shown that the left-hand side of the equation is equal to the right-hand side, and that's all we needed to do. Okay. Next example, we are to show that sine is an odd function. So we have sine negative x, and if it is if it is an odd function, then it should be equal to negative sine x. So what we'll do is expand the left-hand side. So we have, instead of negative x, we have 0 minus x, which of course is the same thing. Then we can use the difference identity for sine and rewrite this as sine 0 cosine x minus cosine 0 sine x. As we know, sine 0 is equal to 0, and cosine 0 is equal to 1. Then the left-hand side becomes just 0 minus sine x, which of course is just negative sine x, and that's the same as the right-hand side, so we now know that sine is an odd function. Okay. Moving to the next example. All right, so sine alpha is equal to 7 over 25, where alpha is in quadrant 2, so from pi over 2 to pi, and we're to determine the value of cosine 3 pi over 2 minus alpha. So what we can do in this case is first use the difference identity for cosine. So that is cosine 3 pi over 2 minus alpha is equal to cosine 3 pi over 2 times cosine alpha plus sine 3 pi over 2 sine alpha. Now, as we know, cosine 3 pi over 2 is just equal to 0. So we have actually the first term is just 0 times cosine alpha, which is just 0 altogether. And we also know that sine 3 pi over 2 is -1 sine alpha. So we're just looking at negative sine alpha, and we are given that sine alpha is 7 over 25, so we just have negative 7 over 25 for the value of cosine 3 pi over 2 minus alpha. That's it. So example number 2 on this page, we are trying to solve a trigonometric equation that involves a double angle, so cosine 2x. So what we're going to do here is first use the double angle identity for cosine. I'm going to use the version that involves a cosine square x. So it looks like this. And the right-hand side is still 2 cosine x. All right, now we're going to move every single term to the left-hand side. So notice that these are mostly in terms of cosine. So cosine cubed x, and then cosine square x in the second term. In the third term, we have -2 cosine x, and finally -1 at the end, and it's going to be equal to 0. Okay, notice that the greatest common factor in the first two terms is 2 cosine square x, and then we're left with 2 cosine x and a +1. In the last two terms, we can factor out just a negative sign, and then we also have 2 cosine x +1 there. And the right-hand side is still 0. So the first half of the expression on the left-hand side now contains 2 cosine x +1, and so that's the second part. So now what we can do is factor that out. So we have 2 cosine x +1, and then what's left over is 2 cosine square x -1. Still going to be equal to 0 on the right-hand side. So now each one of the two terms is a trigonometric expression. The first one, we're looking at it equal to 0 when cosine x is equal to -1/2. And the second part, the 2 cosine square x -1 part, that's going to be equal to 0 when cosine x is equal to positive or negative, because of the square, 1 over √2. So from there, the first part we have when cosine x is equal to -1/2. Well, that means that x is going to be equal to either 2 pi over 3 or 4 pi over 3. Using the special triangles. And then for the second part, we have x is equal to pi over 4, 3 pi over 4, 5 pi over 4, and also 7 pi over 4. Okay, so from there, we can rewrite this as general solution because the domain is not specified in this case. So for general solution, we have x is equal to pi plus or minus pi over 3 plus the period of 2n pi, 2 pi n, where n is an integer. So the pi plus pi over 3 gives us 4 pi over 3, and the pi minus pi over 3 gives us 2 pi over 3. And then the second part of the solution is going to be the pi over 4 solution, so that will be positive or negative pi over 4 plus n pi, where once again n is an integer. So again, we started by using the trigonometric identity in this first step, and then we used what we learned in the simplifying expressions and factoring to factor this trigonometric expression into solvable parts in the last part here. Then we found the solutions for cosine x in both the first part and the second part of the equation, and each one of those give a different solution. In the first case, cosine x equal to negative 1/2 gave us these two solutions, and then of course cosine x equals to positive or negative 1 over root 2 gave us these 4 solutions, and finally we wrote those for the general domain. Okay, one more question. So example number 3, double angle identity for I guess this is cotangent. Alright, so I'm going to go ahead and rewrite the denominator on the left-hand side. So that will be, we have cotangent theta, and we're going to rewrite 1 as sine square theta over sine square theta. And then the second term is going to be, of course, cosine square theta over sine square theta, since we know using the quotient identity that is what cotangent square theta is equal to. So notice that we have a common denominator in the lower part here, and that is sine square theta, and of course sine square theta plus cosine square theta is equal to 1 using the Pythagorean identity, so we actually can rewrite this as just the following. And that's it. And then from there, of course, we can rewrite this as cotangent theta and multiply by sine square theta. And finally, we can then rewrite cotangent theta as cosine theta over sine theta, multiplied by sine square theta, of course, still there. And then in this case, of course, the sine theta one factor will be eliminated from both the numerator and denominator, and then we're finally left with just cosine theta sine theta, which is of course the same as the right hand side. So that's one way of proving this identity. Is one of the more efficient way of doing so, just because of simplifying the denominator is quite quick, especially when we use the Pythagorean identity as we did here. Okay, so just a few more kinds of examples that in regards to trigonometry that we went over today, and that's it for today. So once again, thank you so much for listening.